Welcome to the homework solution tutorial. I will be covering 2D to 2E. In this question, it is number 25 through 27. Take a look. These all look like it is a trinomial and the a does equal to 1. Since the a is equal to 1, we can use our traditional x method to find p and q. Okay. I'm trying to find two numbers that multiply to make negative 18 that adds negative 7. So what are those two numbers? Let's try 1 and 18. Doesn't work. 2 and 9. Yeah, 2 and 9 looks like it does work. 2 and 9. But remember, one of them has to be negative because, again, we have to multiply together to make negative 18. So I'm going to try negative 9. So negative 2 plus 9 gets you a 7. That doesn't work. So what we need to do here is we got to take out that negative from that 2, and it should be a negative 9. Okay, let's put that negative on the 9. Let's see if that works now. 2 times negative 9 does still get you negative 18, and 2 plus negative 9 does get you your negative 7. That is the reason why that combination works. So your factors here would be 2 and negative 9. In factored form, it would be x plus 2 and x minus 9. All right, now to get into solutions, we can now just set it equal to 0. X plus 2 equals to 0, and then we also have x minus 9 equaling to 0. So we can minus 2 to both sides. This leaves you with x is equal to negative 2. Then we can add 9 to both sides for this one, getting you x is equal to 9. So those are your solutions. We can always check by graphing it in Desmos. So let's type it in. X squared minus 7x minus 18. Okay, let's check the x-intercepts here. Wow, it looks really good because notice, let's zoom out. Yep, right here. You have negative 2 and 9. Right here, let me zoom in here. So that is your negative 2. X is equal to 9 and x equals to negative 2. There you go. That's how you know those are correct. All right, let's do 26. Ooh, these look interesting. All right, so again, a is equal to 1, so we can use our traditional P and Q method. Let's put it in our x. Here we have negative 16 and 64. We want to find two numbers that multiply to make 64. So 1 times 64 doesn't look like we can make 16. 2 and 32. Nope. What about 3? Nope. 3 is not even good. What about 4? Let me do that division really quick. 4 goes into 6 one time. 1 times 4 is 4. Minus that gets you a 2 here. Bring down that 4. 4 goes into 24 8 times. 8 times 4. No, 8 times 4 is 32. 6. 6 times 4 is 24. Yep. Yay. You see? Always double check your work. Okay. So it looks like 4 and 16. Can we get that? No, that doesn't look right. We can't make 16. We can't add that, right? So that wouldn't work. Let's keep going. What about 5? Nope. What about 6? Nope. What about 7? Nope. What about 8? Yeah, maybe. Let's try 8. 8 goes into 64 how many times? Oh, 8 times. 8 times 8 is 64. Oh, wow. That is very interesting. Okay. So your two values here are 8 and 8. But they have to multiply together to make 16. The only way that is possible is if both of them are negative. Let's take a look. Negative 8 times negative 8 will get you a positive 64. Negative 8 plus negative 8 does get you a negative 16. So your factors can be written as x minus 8 and x minus 8. Now, if you want to find your solutions, we just set it equal to 0. X minus 8 is going to be equal to 0. And then also we have another x minus 8 equals to 0. We will add 8 to both sides to solve for x, leaving you x equals to 8. The same problem here, so we add 8 to both sides, leaving you with an x equal to 8. So their solutions are 8 and 8. This is called repeated roots or zeros. Watch what happens when I graph it. You're going to see why it appears twice. Okay? So it's a x squared minus 16x plus 64. Do you see here where the parabola is? It touches the 8 right here. The reason why there is 2 repeated roots is because, remember, when we talk about our decreasing interval, so it goes down, it hits 8, and then it goes up from 8. So there is an 8 for when it decreases and an 8 for when it increases. That's why it's repeated here. So these are called repeated roots. And 8 would be it. You would say there's one unique root, and there are two, but there are 2 roots. Okay? This one, this looks very interesting. This looks like I see a difference, and I see what? A square here, and I see a square here. So this is going to remind us of our difference of squares. The difference of squares is a squared minus b squared will always be written in that format of a plus b and a minus b. So let's write this in terms of 2 squares. We put in an x here, and what squared is 225? 5 squared is 25. 10 squared is 100. 15 squared is 225. Yep. So it would be 15 here. So your a is equal to x, and your b is equal to 15. So we can now do this. So x squared minus 225 can be factored into what? X plus 15, and x is equal to 15. X minus 15. This is your factored form. To get into solutions, we have to now set it equal to 0. So you have x plus 15 equaling to 0. And then you have your x minus 15 equaling to 0. You want to subtract 15 to both sides. To do the first one, leaving you with s is equal to negative 15. Then you want to add 15 to both sides here, leaving you with x is equal to 15. So those are your 2 solutions, negative 15 and 15. Let's just graph it on Desmos to just double check our work. X squared minus 225. This should be a very symmetrical object. Yep, negative 15 and 15. That's how we know our answers are correct. So there you go. That was questions 25, 26, and 27.